innovation can be on a system level, of course. Smart energy management, the AI algorithm to maybe detect some kind of arc faults, but also when it comes to semiconductor solutions as such. So talking about silicon carbide, talking about gallium nitride, we can, let's say, using this kind of materials, we can shrink down more the size. I would say we're just at this tipping point in the market where the first players will come with gallium nitride and big market players are about to adopt such technologies.
This is the Podcast for Engineers, the podcast you just have to listen to if you're interested in what's going on in the semiconductor market. My name is Kelsey Markl, your host, and today I'm joined by my colleague Jonathan Schmitt, who is the Global Application Manager for Photovoltaic and Residential Energy Storage, which is quite a mouthful. But Jonathan, thank you so much for being here.
Thanks for having me.
Yes, today we've talked about photovoltaic in the past, but it's been more than a year, I think, since we've covered the topic.
Correct.
And today we wanted to talk about some newer developments in the photovoltaic space, also look at wide bandgap technologies. But let's start with the big picture. What's going on in the photovoltaic industry?
So generally speaking, the industry was growing tremendously over the last years. In residential, commercial, and utility, we see a lot of complexity, a lot of different systems involved. So we started with a pure solar inverter, then we have this hybrid inverters. We have a DC coupled with the energy storage, maybe even DC coupled with the EV charging. We have new materials coming in which are bringing more power dense, more efficient systems such as silicon carbide, such as gallium nitride. And also we see a lot of innovation in the higher power classes where we see in the central inverter, but also the string inverter. They will getting pushed to more and more power. So from initially 300 kilowatt to 400 kilowatt to 500 kilowatt. So it's quite an exciting time for this industry, and we saw this rapid growth, and let's see how this further will go.
Yeah, okay. And I'm sure you saw a lot of those trends at the Intersolar, which happened, a couple of months ago. Correct. Now in Munich, right? Did you attend?
Yes, I was there.
Any impressions?
I was hoping you asked me. So at the Intersolar, we saw all the big players of the industry being there. Actually, it's if not the biggest event in Europe and one of the biggest globally. What we could see is that a lot of the big players, they are now serving the complete market, from residential solutions, if it's an optimizer, a microinverter, to the commercial solutions, 100 kilowatt, 150 kilowatt string and hybrid inverters. And then also utility solutions, central inverters, high power string inverters. We see more and more also adopting the energy storage. And there are a few buzzwords going around, such as AI, smart energy management, and how they can, let's say, optimize the system, charge, discharge, and also in regards of the grid forming capabilities. So that's big buzzwords out there in the market, and we had all the players there showing their new solution. It was very exciting.
Sounds very dynamic, if I say. I assume the market itself is also quite dynamic. Can you explain a little bit about how the players are acting?
Well, we were now coming from a huge growth over the last year. So we were more than 40% growth for some years. I always describe it a little bit as the S-curve. So we had a slow start, 2015, and then we had this exponential growth, especially over the pandemic till now. Even from last year to this year, we saw, I think, plus 13% growth of installations. We have more than 600 gigawatt of solar capacity being installed in 2025. What we expect now is that we stay at this high level, and the growth will, let's say, plateau a little bit, but we are still on the growth path on a very high level. But of course, the industry need to compensate that. The grid needs to also being developed in a similar pace, because that's also, the solar is very much connected to the grid. The energy storage needs to also catch up with this one. And when all of this is coming in place, also we expect maybe some more consolidation in the market. Correct. That's basically the high level view.
And you mentioned consolidation and all of this opportunity. For inverter manufacturers, are there a lot of players out there? Is it competitive?
Very, very competitive. Even we can here, let's say, differentiate a little bit between residential, commercial, utility. The most players are surely in the residential area, where we see a huge competition, hundreds of players from all the regions globally. Of course, China has a little bit a special role because they are by far the most players bringing up the solutions. They developed, very, very fast their solar industry over the last years. For the export markets, but also China is the market who has the most installations domestically. Then going to the, let's say, higher power classes, the competition gets a little bit less, but still that's super competitive markets. Solar is in a way also price driven. So we want to have the energy coming for less and less money. And we actually achieved it already. So solar is the cheapest energy form globally, which is very, very good news. And therefore, we also see this rapid growth coming forward.
And a huge development just over in the last 10, 20, 30 years. So you mentioned that there were a lot of players, and both in residential, photovoltaic, but also utility commercial. Pricing might be one side of things, but what about innovation? Where is the innovation coming from in the market?
Yeah, so currently, innovation can be on a system level, of course, and we see more software-defined systems, of course. So this is one part of the innovation. I said it already. Let's say smart energy management, the AI algorithm to maybe detect some kind of arc faults. That is clearly innovation, but also when it comes to the semiconductor solutions as such. So talking about silicon carbide, talking about gallium nitride, we see this today being slightly more relevant to the residential solutions, because here we can, let's say, using this kind of materials, we can shrink down more the size, for example, and bring down cost. And this is to an end consumer where cost matters again a little bit more after all. But then also, especially silicon carbide, we see also in the higher power classes. It's not only in residential, also commercial utility, it can be used. Otherwise, we see a lot of IGBT solutions there as well. And then again, coming back to gallium nitride. So today, I would say we're just at this tipping point in the market where the first players will come with gallium nitride. I just name a few applications. The microinverter application, as is very big in the US market, but also coming more to the EMEA market. So there we see on the secondary side of the microinverter a clear value proposition of gallium nitride. Not only to say there's also some special new switch technologies, the bidirectional switch, I believe we will elaborate this still a little bit. And then also for the power optimizers, shrinking them with gallium nitride or the string inverters / hybrid inverters. This is very exciting. Again, it's at this tipping point, the first players already adopted. And big market players are about to adopt such technologies, while having a little bit also an eye on silicon carbide. I would even say silicon carbide is a bit more already mature in the market, especially when we look to residential energy storage. The bidirectional DC-DC stages to the battery, we see that often already by today already being done. So the value proposition is very clear. The technology is there for a long time. So this is the major technology trends we're seeing being adopted right now in the market.
Okay, yeah, we've talked about silicon carbide a lot in the past in both terms of ESS and also photovoltaic in the past, EV charging, these systems that you were describing earlier with the integrated ESS and solar and maybe even a bidirectional DC wall box, for example. But let's look at GaN, because like you said, we're at the tipping point. It's new. What are some of the clear advantages of GaN in inverters?
Well, the technology as such, or the physical properties, let's say, or electrical properties, they already show that I have less losses, that I can handle maybe better heat. I can let's say bring up the switching frequency much higher in the system, and this has a huge impact on the overall design of such a system, because there's a relation between the passive component, the filter size, and so on and so forth. So when I push up, or when I go with gallium nitride and I, let's say, push up the switching frequencies, I can of course reduce the system size, so it's more power dense. But not only power density, it's maybe not even the most important point, but what I'm talking about is the overall system cost, which can go down. And this is then a win-win situation, because on one side you have a let's say, under certain circumstances, more efficient system, or you have a equally let's say efficient system, but let's say for a reduced cost, and for a smaller size. So this is a clear value add of this kind of technology.
Okay, reducing system costs often comes hand in hand with changing the topology. Is that the same case when you use GaN?
Correct. So we see, depending on the sub-applications, a lot of different topologies. When we look, let's say, start with the optimizers, there's a buck boost topology. Here we see that let's say mid-voltage GaN can maybe replace the silicon switches which are in there, but also on the silicon we are on a very, very good level already. So it's a bit the decision between price, performance, and the highest efficiency solution in the market. And then where it's even more shining by today is the microinverter solutions, where we have classical topologies in the past, some kind of flyback plus unfolding stage, and we see more and more topologies like single stage topologies. We call it also cycloconverter topologies. And here on the secondary side, we have, so to say, this back-to-back switches. Depending on, of course, on the setup, let's say there are like two back-to-back switches, which can be today two silicon superjunction switches with Infineon, our CoolMOS devices, for example. And there we see a huge benefit, because it can be a 1-to-1 replacement or 2-for-1 replacement with our GaN bidirectional switches. So where we replace two of the back-to-back silicon superjunction switches with one of the GaN bidirectional switches. So I have the system benefit there, with going down and shrinking the size and so on and so forth. But then I have also 2-for-1 replacement, which is of course also in PCB size. It's just smaller, and eventually also the pricing is going to a more attractive level for our customers.
Yeah, of course, fewer components is also a benefit for the system size, right? You mentioned, though, a word, cycloconverter, which I have to admit is a completely new term for me. Can you explain a little bit about what a cycloconverter is?
Correct. Yes, let's do so. So when we look in the past, the typical topologies, where I would call it now two-stage topologies. There are a bunch of them which are current source or voltage source topologies, but let's keep it like this. And now there's this shift to a single-stage topology. So I don't have this intermediate DC-DC conversion, so I have a direct DC to AC conversion in my cyclo topology, which makes it more attractive in a way of less power conversion steps, less losses, less semiconductor content, which is also reducing cost after all. And this is paired with a very high efficiency already. Plus then the usage of gallium nitride, I can even, let's say, bring this up. And yeah, it's, so to say, I have a lot of win situations in this kind of topologies. Not saying that the other topologies are, let's say, bad, but we see clear improvements going in this direction, and using such kind of topologies.
Okay. Well, we've given a good stage to GaN so far, but I don't want to forget GaN's sister, silicon carbide. Correct. When would silicon carbide make more sense in the photovoltaic space?
Well, usually we see last comment on gallium nitride being applied to lower power systems. I talked about optimizers, microinverters.
So residential side.
So yeah, but silicon carbide is also on the residential side. Okay. But there's a difference because an optimizer can be, let's say, a 500 watt solution, or a microinverter can push up 600, 800 watt whatsoever. This is the range. I can also put gallium nitride in a 6 kilowatt inverter, but then we see suddenly silicon carbide more shining currently. So being clearly above 10 kilowatt, 20 kilowatt, and so on and so forth, we see more and more silicon carbide. That also has to do with the availability of voltage classes. So higher power systems are often three-phase systems. Three-phase systems require 1200 volt devices. And what is out there today in the market for gallium nitride solutions is rather below 1000 volt. So 1200 volt silicon carbide is super mature in the market, very reliable technology. And seeing this, so there's naturally already the room for silicon carbide. And then we see it a lot applied in the bidirectional DC-DC stages for the energy storage. There are topologies like CLLC, DAB topologies, but also in the classical buck boost topologies, it can be used. What we now witness is that a lot of the inverter stages, be it now single phase with Herrick or three phase with an NPC2, as for example, that there's also now more of an adoption of silicon carbide, be it 750, 650 volt, or be it even 1200 volt or above. So this is residential. When I look now in commercial and utility scale systems, in this higher power, so we see more and more modules also coming into play. So in the past, that was a lot of IGBT-based modules. So IGBT is a silicon-based technology, but also there we see at some customers that they use silicon carbide because they can push the efficiency, let's say, a little bit more, and the return of investors coming also earlier. So this is also where the silicon carbide is getting into. So really, really high power classes, so silicon carbide based power modules. And then, of course, in the classical three-phase systems, which start at a residential, let's say 6 kilowatt or higher, and can go up to 20, 50, 100 kilowatt. This is where silicon carbide is then also shining, and gallium nitride naturally is then more on the lower than 10 kilowatt arena.
Okay, so it seems like there's a lot of options for designers when looking at topology, technology, different packages you can go with. Is there anything that can help designers get a head start when designing their system?
Correct. Actually, this is a very, very interesting topic because also I was personally involved in a very interesting project which we had here internally, where we designed a so-called modular hybrid inverter platform. So that is a platform from a PV boost stage to inverter stage to a bidirectional DC-DC stage, which can help players in the market to evaluate quickly the technology and bring this in their own design. So we have done this on a silicon IGBT basis, so silicon, the H7 technology, the fast switching technology from Infineon. And then we did the same basically with our silicon carbide Gen 2. So we saw one option is definitely a kind of price performance option going in the IGBT area. We see nevertheless very, very solid results going in this direction. IGBT is a very robust technology, proven in the market and known for years to come. But now we also show with the silicon carbide what the designers can actually reach in this kind of, with this kind of technology when it comes to, of course, efficiency, power density, but also we bring in new innovations such as topside cooled packages, because also the IGBT we see a lot now with the TO220, TO247, very classical through-hole devices. Mm-hmm. And now we see with the topside cooled packages where we can, let's say, bring them on the backside of the PCB, and then we mount on one side the heatsink, and on the other side are all the electrical components. This is also quite beautiful in a way that you let's say, separate the thermal path and also the electrical path, because the gate drivers will come from the other side. And that just brings you some system advantages. And with this design, we bring all these design considerations into account and can showcase this quickly for evaluation and a quick head start to our customers.
Okay, yeah, it's a lot of options that designers must be weighing in their heads.
Correct.
So good that we offer something. If we take a step back completely again, then and look at the whole market as a whole, from residential to commercial to utility, what are the biggest challenges that the market's facing right now?
Well, in the residential area, I would say the biggest challenges is definitely price. The systems needs to come down in cost, and
which it has a lot, right?
Which it has a lot, but still it's under a lot of pressure, because one of the first statements was also that the market is pretty crowded. That means also reducing costs, and also their target markets such as India, South America, Africa, which require very cost competitive solutions. And now while let's say the wide bandgap devices come maybe for a slightly premium price, we have to now account the system benefits coming with it, because with that you can really bring down the cost. So this is at the moment the challenge designers have on hand, to come to these new technologies, to fully leverage their benefits in order to bring down the cost. So this is something to solve in the residential area. Software is a big topic, which is over all the let's say power classes a really important topic, because that's core IP of the players out there. And if they have the better, let's say, software-defined inverter system, where you have a great, let's say, communication between the inverter, the power stages, let's say even the apps for the monitoring, and the end user, so that can make really a difference to bring that in, collect this data, use this data, improve with this data the inverter performance. And then coming to higher power classes, I think there's one buzzword which is a big challenge, is grid forming. Because the solar energy, of course, needs to be is a clean energy, but for the grid, it can be a slight burden. And if I have this grid forming capability, it's a much cleaner energy, and it doesn't. It's like easier, let's keep it in simple words, easier for the grid to digest, to get into the grid and getting then distributed. Otherwise, of course, it can also get stored in energy storage. And then again, there's the same challenges with the grid forming capabilities as, for example. So this is the higher you go, this is usually the challenges on hand. There's also this kind of overvoltage, overcurrent events where a lot of players are concerned on, and this comes down again then to reliability, or to the quality reliability topics of our semiconductor solutions. That's what we see as a basic feedback in the market.
Okay. And if you, with all of that in mind, all of these challenges that they're facing, all of the options that they have when designing new systems, where do you see the industry developing over the next few years?
So we see more and more players doing basically everything. So while we want to be a one-stop shop for our players, or for our customers want to be a one-stop shop for their customers, of course. So being very relevant in all the different segments with all the different solutions, that is something which will happen, of course. While I talked about how the market is growing, so we went from this exponential curve to more, let's say, single-digit growth. We reached this plateau over 600 gigawatt, maybe reach 700 in a soon future. There will be more consolidation in the market. Even at some point we have already consolidation. So I just saw the newest market data that, for example, in 2024, the top 10 players account for, let's say, 80% of the market share. Nonetheless, in this 20%, there are hundreds of players. So it's clear that not all of them can survive. And it's also clear that some of them are the rising stars of the future. So we will come to a more healthy ecosystem. Players will come out of the market. Maybe some more players will join the market. That's also something we see, that not only the inverter players try to do everything, we also see sometimes even from home appliances coming over more players and going into the solar. Also the battery makers, as for example in the industry, they are already doing this because they have, for example, a core component, which is the battery, of course, and doing the power electronics around to come to an energy storage is not such a fast step. So things like this will happen, but always in mind, it's a very cost-driven industry. It was very, very dynamic in the past. I think the players who are most agile, who can adapt the fastest, they will win. And this might be the future of this industry, yes.
Okay. Thanks a lot. Thanks a lot for your insights and sharing about photovoltaic and how things are changing.
Yeah.
And to our listeners, thanks for listening. Thanks for watching. And please stay tuned for more episodes from the Podcast for Engineers.